All right, now let's discuss covalent bonding. When you have a covalent compound, there is got to be some kind of sharing of valence electrons. So co means together. So consider that there are two atoms that are together and they are sharing their valence electrons. So in order to be able to figure out what a covalent compound really looks like, you need to know how many valence electrons each compound or each atom has. So let's look at a relatively simple one first. We'll look at water, H2O. So water has two hydrogens and one oxygen. And just to break it down for you, we're going to look at the valence electrons for each of these. So the first hydrogen has one valence electron. The second hydrogen also has one valence electron. And if you recall, oxygen has 6 valence electrons. Now, keep in mind also that oxygen wants to have 8, and both of the hydrogens want to have 2. Well, there's really just not enough electrons to go around for somebody to steal some from anyone else. So what they're going to do is actually share. So this hydrogen might share this electron with the oxygen here, and this hydrogen might share its electron with the hydrogen here. And what that's going to result in is the oxygen with its own 6 electrons, and the hydrogen having come in now is sharing its electron with oxygen, but is also sharing this lone electron on oxygen. So this hydrogen gets to pretend that it has 2 electrons, making it very happy. And the other hydrogen as well now has the ability to pretend it has 2 electrons. And if you look at oxygen very carefully, it can pretend that it has 8 electrons. So this is a very stable molecule. Everybody is sharing their valence electrons, and everybody has a completely filled outer shell or valence shell. This would be a covalent compound, okay, when everybody is sharing. Remember, ionic is when an atom would just steal electrons and create charges. There's not really much of a charge happening here, at least for our purposes right now. We'll talk about polar, nonpolar molecules in a little bit. But notice that you've got your H2O, 2 hydrogens bonded to 1 oxygen, and this is really a molecule. Okay, so when you have covalent bonding, you actually have a molecule, a single molecule with 1 oxygen and 2 hydrogens. As opposed to with ionic compounds, it was really just telling you the ratio of ions in the particular compound or unit. Okay, so let's look at another one. I'm going to give you, let's do ammonia, NH3. So we already know each of those hydrogens, there's 3 hydrogens, each of them has just 1 valence electron. Nitrogen has 5 valence electrons. So these 3 hydrogens can bond very happily with this nitrogen. Here's one that's going to share its electron. Here's another one that's going to share its electron. And here's a third one. So again, what I want you to see here is that hydrogen can pretend, each of these hydrogens can pretend that they have 2 electrons, fulfilling their need for that octet rule. But remember, they're an exception to the octet. They now have 2 electrons in their outer shell, and that makes them very happy. Nitrogen here does have a full octet, and it is very, very pleased, considering it can pretend it has 8 electrons in its outer shell. Okay, so in the next video, we'll talk a little bit about naming rules for covalent bonding. I told you this was water and this was ammonium, but those are the common names. Those are not the scientific names for these, and I'll show you how to determine the scientific names in the next video.